We're up to lesson 15 now. This one is about naming molecules that have more than one different functional group in the same molecule, right? So we run into the difficulty that if one of the functional groups makes up the name of the main chain, then how do we name the other functional group or groups that are also in the molecule, right? Because now they can't also be the name of the main chain, right? And so what's developed is a priority list, right? Which I have here behind me, right? Highest priority is number 1 up at the top of this list, right? Down to lowest priority at the bottom of the list, right? Where the higher the priority of a functional group in the molecule, right? It becomes the main chain of the molecule. So for example, up here, the top priority in this case is carboxylic acid amongst the list that we have here. And so since there's nothing higher priority than a carboxylic acid, if a carboxylic acid is in the molecule, right, it will automatically be determined to be the main chain, right, or the main functional group of the molecule. And then anything else that's in the molecule will have to be named as a branch or a side chain, right? Now, we already know what this is like because we started off naming alkanes, and as you can see here, alkanes are actually priority number 10 in the list, which means there are two things, ethers and halogens, right, which are lower priority than alkanes, meaning we already know how to name two functional groups, right, without actually making them the main chain of the molecule name, right? Since an alkane takes priority over ethers and halogens, we always name the main chain as the alkane chain, right? And then we name either the ether functional group or the halogen group as a branch, right? And we did this already way back in the first lesson on functional group naming, right? And we can see this is why there's no suffix. The suffix is not applicable for ethers and halogens, right? Because they never make up the name of the main chain. They don't change the suffix, right? The suffix will always be ane for the alkane, right? And then we name an ether, right, as an alkoxy branch prefix, right? Wherever you see alk, right, that just refers to alkane, right? The alk part at the beginning. So that could be your meth, F, prop, right? So you could have methoxy or ethoxy or propoxy or butoxy or pentoxy. So the alk part is your usual numeric prefix, right? And you just put that on the beginning of whatever the alkane chain is, right? And same thing with halogens, right? Halogens don't change the name of the main chain. We just name the alkane as we normally would. And then halo just means it could be fluoro or chloro or bromo or iodo, right? We just name that as a branch on the alkane chain, right? Then we get up to the 10th list, alkanes, and we learned how to name alkanes. We just put the ane suffix at the end, right? And then we start getting into things that are of higher priority than alkanes. That's when the ends of the name actually start to change. And that's what we saw after we did ethers and halogens in the first functional group lesson. We saw that all the other groups that we talked about, starting with alcohols, changed the end of the name. It's no longer ane, right? For alcohols, it's alls, right? Then we talked about alkenes and alkynes. We changed it to ene and ine instead of ane. Then we talked about aldehydes and ketones, change it to al and one. Esters and carboxylic acids, change it to oic acid and oate. Amines and amides, change it to amine and amide respectively, right? So all we have to do now is say, well, what are the prefixes that we would use like alkoxy and halo for other functional groups if they're not the priority, right? Well, they all get a different name. So for alkene and alkyne, right? So notice the prefix for alkanes is alkyl, right? Well, we already know what that means, right? If we have a side branch that's 1 carbon long, we call it methyl, right? Or F-il for 2, or prop-il for 3, right? Well, if it was a double bond as a side branch, right? Well then, instead of just F-il, right, which would be for only a single bond with 2 carbons, it would be F-ine-il, right, Y-N, for if it was a triple bond, or F-ene-il, right, if it's a double bond with 2 carbons as a side chain, right? So we're naming it the same way. It would be, you can have propyl if it's an alkane side chain. You can have propenyl if it's a 3-carbon with a double bond in it, or you can have propinyl if it's 3 carbons with a triple bond in it. Right? If we have an amine, right, but we're naming it as a side chain, we use amino, right? Alcohol, we use hydroxy, right? And we're actually going to see why amino and hydroxy actually make sense. Ketone, oxo, aldehyde, formal, amide, carbamyl, ester, alkoxycarbonyl, and then there is a prefix for carboxylic acids, which can be used if you say have multiple carboxylic acids, and one of the carboxylic acids makes the main chain, and then you need to name another carboxylic acid as a separate side chain, right? Because of the way the molecule looks, right? Then you can use carboxy for the second carboxylic acid. Right? So those are the names and the priorities. Right? So let's just look at an example. Say I start with a carboxylic acid. Right? So that's my carboxylic acid group. Right? Its highest priority. So anything else I put on this molecule is now going to be of lesser priority and has to be named as a prefix. Right? Let's just say that it's an alcohol group. So I'm going to put an alcohol over here. Right? So how am I going to name this? Well, the carboxylic acid takes priority, so I ignore the alcohol for now. Let me actually write the alcohol in red, just to signify that this is the side chain. Carboxylic acid is going to get priority, so it's going to be carbon number 1, 2, 3, 4, 5. So this is a 5-carbon main chain. This is pent and oic acid. So that's my name, my main chain name, right? And now I can see on the 3rd carbon, I have my alcohol, right? So what am I going to use as a prefix for my alcohol? Well, that's hydroxy. So just to make myself some room up here, take that out for now. We already know all the suffixes, right? So now I'm going to say it's on the 3rd carbon, there's a hydroxy group on my pentanoic acid, right? Rather than naming it as an alcohol, right? And the name hydroxy, I think, actually makes a lot of sense, because if you look at just the OH part, right? What is normally OH just on its own, right? It's got a negative charge. It's hydroxide, right? So OH by itself is called hydroxide, and so when we talk about OH, right, as a side chain, we call it a hydroxy side chain, right? And I can do all kinds of things. I can replace it, right, with, instead of with a hydroxide, I could make it a ketone, right? Then it would be 3-oxo pentanoic acid, because the pentanoic acid is still the highest priority, right? And now the lower priority is the ketone, and I use prefix oxo, it's on the 3rd carbon, so it's 3-oxo pentanoic acid, right? I could replace it with an amine, and I could put an NH2 there, right? And this one also makes a lot of sense, right? It's an amine, right? So as a branch, why not call it 3-amino pentanoic acid? Right? And then maybe some of the more difficult ones, right? I mentioned the alkenyl and alkynyl groups, right? So if here, if I put something like that, right? That's got 1 carbon, 2 carbons, right? So it's an F, right? But it's got a double bond in it, so it's no longer ethyl, it's F-ene-ill. And it's on the 3rd carbon, so it's 3-ethenoyl pentanoic acid, right? And I could just as easily make it a triple bond, in which case it would be F-ine-ill pentanoic acid, right? And you can see how this is all going, right? So that's pretty much the system by which it is. You just find the functional group. If there's more than one, you find the one that's highest on the list, right? And you make the one that's highest on the list be your priority, right? Find the longest chain that includes the highest priority functional group, and that becomes your main chain. Name that main chain. Ignore anything attached to it, right? Number it accordingly so that your highest priority group gets the lowest number, right? Then, once the main chain is named and everything is numbered, right, well then start putting everything that's attached to it using the appropriate prefix, right, as branches on your chain. Right? So it's not all that bad. It's just a matter of starting to learn some new names. Right? And it's obviously much more helpful if you were perhaps given that chart as a reference.